Good evening. This is EMH Math Portal lesson solving exponential expressions, and this is Irvin Howard, your math tutor for math for EMH Math Portal, and this is the final video in which you'll solve exponential expressions using a form of a cognitive load theory or cognitive load strategy, PEMDAS. And PEMDAS is simply representing the PEMDAS. All right, PEMDAS. You can say, please excuse my dear Aunt Sally. All right. So what that means, please excuse my dear Aunt Sally, it's a form of a mnemonic that we use for solving arithmetic expressions, or what is known as order of operations. And that represents in the order of operations, parentheses, exponents, all right, multiplication, division, addition, and subtraction. All right. What we're going to do, kind of different. We're going to use that type of technique to solve exponential expressions, along with the practice of formula writing. And based upon the other series, the videos that you've seen, the other video series involving exponents, I want you to learn how to write your formulas along with solving the expressions, so that it'll help you to memorize some of the techniques, so that you can formulate these ideas and strategies in your mind, so you'll actually know the application, know the formulas and how to apply them just by following these steps. And PEMDAS is going to really help us solving these types of exponential expressions involving more than one type of technique to solve them, which combines your various exponent rules in solving exponential expressions. But let me give you an example, several examples, maybe one or two. I believe three. Three will be sufficient. For example, I'm going to write this expression, example number one. All right. Example number one involves an exponential expression, x to the 6th power, y to the negative 2, over x to the negative 2, y to the 3rd, surrounded by the parentheses, raised to the power 2. So you have an expression involving the quotient rule inside the parentheses, and outside you have this power raised to power 2. So what we're going to do, we're going to kind of take it a step at a time using PEMDAS. Okay, please excuse my dear Aunt Sally, which is the P represent parentheses, exponents, multiplication, division, addition, subtraction. We're going to look at each of these steps that make up this acronym in solving this exponential expression. But what we're going to do this time, we're going to use it as a checklist. So we're going to look at P, parentheses. Since we have parentheses, we're going to look in the parentheses, and what's around the parentheses is this expression. So we're going to look at it, and we're going to just do a checklist at a time. So we're going to work with P, which is parentheses. And inside the parentheses is your expressions. We have a quotient. So we're going to use the quotient rule of exponents, and we're going to examine each of them and use the formula writing so that we can examine each of the terms. So since This is a quotient, right? So we're going to apply the quotient rule, and we're going to just bear with me. We're going to put everything at the top because we're going to show the expression using the formulas as formula writing. So when we use the quotient, the quotient a raised to the power m over a raised to the power n, you're going to take the difference. All right? You're going to take the difference. And we're going to use this strategy so that we can put our expressions together. So we're going to do this. We're going to identify our exponent of x. All right? And then we're going to use this to take the difference by applying the quotient rule. 6 minus parentheses a negative 2. Because when we use the formula, you already have a minus, or take the difference. So we have to identify the difference and then the negative by putting in parentheses around it. Negative 2. And then we have y, negative 2 minus 3. All right? And then parentheses, which is this, all right, raised to the power 2. So we're examining each part, okay, at a time. And then we're still working inside the parentheses because we're doing parentheses, and now we do the exponents. After we do the parentheses, when we do the exponent, we apply the quotient rule, all right? And then equal to, then we perform our operations, all right? X raised to the power 6 minus a negative 2. The negative 2 times the negative will give you a positive. So you have 6 x to the 6 plus 2 raised to the power of negative 2 minus 3. Now, you don't have to show all your work, but it's just a way just to show you how you can examine your steps. And later, as you become familiar with these steps, you can skip them. All right? Minus a negative 2 minus 3. A negative 2 minus a negative 3 will give you, this will give you a negative 5. So let's do this. X 6 plus 2 will be your 8 raised to the power of negative 5. Okay? It's all in parentheses. Raised to the power 2. All right? So now it's shrinking. Notice from here to here, you've reduced your problem. So your problems like these don't be as intimidating as they appear, because if you follow the steps, excuse me, and use this technique, you can shrink your problem. It looks a lot less intimidating. Okay, and then what we do next, we still work inside the parentheses, and we also still work with the exponent. We know we have a negative exponent. So when we have a negative exponent, we apply the negative rule, the negative exponent rule, which is a raised to the power of negative m will give you 1 over m, or the fractional equivalent. So instead of this being the numerator, this becomes the denominator. So you just make it as a fraction. You can look at the other series videos that show you practice on your negative exponents. So we take this, x raised to the power 8, and based upon this formula right here, negative 5 is a negative in the exponent, and we have to express it in its fractional form. So it becomes the denominator, and then parentheses raised to the power 2. And then we're almost finished. And then we apply, since we have a raised power for your numerator and denominator, we apply the power rule, which is a power raised with another power, all right, which will give you a product of m. So a raised to a product of m and n. So they're products, so you multiply them together. So let's do that. So we're going to do that for your numerator and your denominator. So in this part, we have x raised to the power 8 times 2. I'll just go ahead and express it. And then y to the power 5 times 2. This will give you x to the 16th power and then y to the 10th power. All right? And that is your final answer. All right? So as you practice these steps, you can continue to use these techniques to show your formula writing, and at the same time apply these rules so that you can practice in your mind, so that you don't have to write these steps, and you'll just even you'll be able to even skip these steps and go right to the heart of the problem. All right, let's try another one. I'm going to take this and turn it over. thing we do in the PEMDAS, we will look at P for parentheses. We look what's inside the parentheses, and we know that in each of the parts in the parentheses, you have a quotient. So if we look at the quotient for X, and the quotient for Y, and the quotient for Z separately in our minds, we can dissect this problem and express it in terms of using the quotient rule. At the same time, after we use the quotient rule to reduce the power within the parentheses, we apply the power rule because we have a negative power. So we're going to show you how to take care of this, but let's follow the PEMDAS way. Work inside the parentheses, all right? So P for parentheses, and then what we do, I'm going to show you this. We're not going to take away the quote, we're not going to take away the fraction, but I'm going to put everything at the top just to show you how we apply the formulas, okay? So what we're going to do, I'm going to keep 4 over 2, okay? But as we apply the formula, we'll apply those particular rules, and then we'll perform the operation after we apply it, and then whatever's left, if you have a negative exponent, it goes back to the bottom. Or if a negative exponent appears, it goes to the bottom as the denominator. Okay, let's try this. So we have X, all right, -1, we're applying the quotient rule, minus 1, okay? Because we have X right here, and if there's not a number near X, it's assumed as the raised to the power of 1, and that's how we got the 1 right here. The 1 right here at the top was already negative, so we can identify that easy. All right, we have Y raised to the power 2, and then we take the difference between this one, because part of the quotient rule, we subtract or take the difference of the powers. And we're going to do that, minus 2. Okay, and then we have Z left. All right, Z to the third minus, which is part of the formula, parenthesis the -3, because this is where the -3 comes in. All right, still surrounded by raised to the power of 2. All right, and as we continue to do this, we're going to reduce it. Now, normally you can go ahead and you can find the difference between, you can reduce this 4 over 2, which is 2, but I just want to prove a point. And we can do that right after. All right, we work inside the parentheses first. All right, 4. Now we find the difference. All right, then the next component of PEMDAS is the exponents. We take care of the exponents, okay, right here. So we have X, -1 minus 1 will give you a -2, all right? Y, -2 minus a -2 will give you a -4, okay? And then -3, okay, I'm sorry, 3 minus a -3, when you have a negative times a negative, you have a positive. So it actually becomes Z 3 plus 3, a positive 3, because this becomes positive, which is 6. Notice I skipped the other step because you understand how to do the other step as far as just writing the problem, because you can do this in your head right now. All right, over 2 raised to the power of -2. We're almost finished, all right? Now, we can go ahead and we can find the value for 4 over 2, which is 2. But as we do that, all right, I'm going to go ahead and put this raised to -2, because we recognize that these are some exponents that will have to go to the bottom, all right? When we apply x raised to the power 2, right, we apply the negative exponent rule, which is a raised to the power of -m, which is equals to 1 over am. So actually this x raised to the power 2 will become 1 over x squared, all right? And that's what we're doing. But instead of it just showing like that, we can simply just take it to the denominator. So any negative exponents that are in the numerator, you can take it to the denominator, and you would render it positive. And that's how we can express that. So we can do this, x raised to the power of 2. It becomes positive 2 when we take it to the bottom. And then we have y to the -4, that becomes y to the 4th, okay? And the only thing that's left in the numerator is x raised to the power 6, which is z raised to the power of 6, excuse me, which is already positive. So whatever's already positive that's in the numerator stays in the numerator, unchanged. If you have an exponent that's already in the denominator positive, you don't take it to the top. You only remove those exponents or switch them if they're already negative. All right. And then we have this 2z to the 6 over x squared y to the 4th. And we're not finished yet. We got to use this one. So we're still on PEMDAS E exponents. All right. E for exponent. We still have this negative exponent. Now, based upon anything that is, this is the formula, and you've already seen this one in the other video. I'm going to put it to the side, all right? See, now, to use this, if you have a negative exponent surrounded by a quotient, this is what you do. This is the formula. A over B raised to the power n. Instead of finding the individual, instead of doing it individually, if you have a quotient already, you can use the advanced version to flip it, to find the reciprocal. And I showed that in the video. Instead of this, then to make this positive, all you have to do is flip it. And you would change the value of the exponent positive by just finding the reciprocal of this. And let's do that. So we're going to find the reciprocal of that, which is just flip this. All right, just flip it. So you have x squared, y to the 4, 2z to the 6, raised to the power of 2. So it becomes positive, right? And as it becomes positive, we can go ahead and apply the other problem of the problem is any exponent raised to a power of an exponent, you take the product of it. So in this one, 2 squared, we're still doing it with the exponent, 2 squared, all right, raise the power for each one of these. Raise this 2 squared to this x squared, which will give you x to the 4. Anytime you raise exponents, powers, you multiply the numbers, okay? All right, but the numbers are different, and I'll show it to you in a few seconds. All right, and then what you do, you raise the power of y to the 4th, 4 times 2, which is 8, over. Now, when you raise the power of 2, you're multiplying the base times itself, okay? You're multiplying the base times itself. So instead, you will actually have 2 squared, all right? So 2 squared is 4. You do the same thing, but the numbers are different because any exponents that you raise the power, you multiply whatever number that you multiply to the power times itself, right? So 2 raised to the power 2 is 4, all right? And then z raised to the power 6, when you raise that to the power, you have z to the 12, all right? And that's your answer. X to the 4, y to the 8, and 4z to the 12, all right? Here we go. All right, and that's your final answer. And I hope that helps. We're going to do one more problem just to illustrate. C to the 3rd, c to the negative 4. And now, in parentheses, raise to the power of negative 3. Okay, again, we're going to use the PEMDAS illustration. All right. So again, P for PEMDAS, the parentheses. We work what's in the parentheses. Again, we're using the PEMDAS as a checklist. So far, we only dealt with part of the PEMDAS involving maybe some addition, some multiplication, and some division. But we really did some division because when we have fractions and raised to the power, all right, we had to still do the exponents, and when we do the exponents, we multiply. But we really seems to be focusing on the first two techniques or operations in PEMDAS, the first two techniques, parentheses and exponent. And see, that's where we stop right there. All right, but maybe we'll probably do some challenging ones maybe in the near future. But anyway, what we're going to do inside the parentheses, we're going to take everything again back to the top using the quotient rule. All right, and notice we have this negative, and we'll play with the negative in a few minutes. Or what we can do, Since we have a negative number in the numerator, I'm just going to write the negative beside this. Okay, it's the same thing. And don't feel alarmed, but I just want to show you that the power of A always doesn't mean that the negative is in the numerator. The negative could be in the numerator or the denominator, and there's different ways to write it. But just follow my lead. I'm going to write the negative, and I'm just going to perform the operations in the exponents, all right? Not the bases, but the exponents, okay? Okay, A to the third, all right? And then I'm going to perform the same thing, all right? And what I'm going to do, I'm going to put the parentheses here. I'm just factoring out the negative, but I'm just putting a negative aside. Don't worry. I'm going to draw a line just to show you the illustrations again, all right? Just to show you the illustrations. So I have the 2 down here. Now I have A to the third, and then I have this A in the denominator. So according to the quotient rule, you take the difference of the bases, and that's what we're going to do. A to the third minus 1, because there's only one power, 1 to the power, or the first power, because there's no exponent there. It's understood to be 1. Okay, excuse me. Then I have my B minus a negative, all right, minus a negative, which is 3, all right, because that's the 3 right here. And then we have C, negative 3 minus a negative 4, all right. Notice I put it in parentheses, okay, all right. And so far, we have it okay, and we have everything at the top if we do the formula writing, okay? Minus, and then let's perform the operation. I'm going to put the 2 here. So we have A to the second power, B to the negative 4, okay? And C, all right, a positive, it becomes positive. And 3, negative 3 minus a negative 4. So we have this negative 4, and this negative. When you multiply a negative, it becomes a positive. So it becomes a positive 4. Negative 3 plus a positive 4 will give you 1. And later, you don't have to put the 1, but it just shows you. It seems to help you, you know, if you write it so that you can understand what is the form of the value. So it's a positive, and we can show you that the 1 will be just regular C to the negative power. And then it's raised to the negative 3, or the cube power, all right? And then what we do, we look at which exponents that have negative values. Any value, any negative exponent, we take it to the bottom because of the negative exponent rule. And that's what we'll do. We'll keep A squared because it's already positive. We have 2. Okay, since this is a negative, we bring it to the bottom and it becomes positive. We already have C as positive, so it stays. And I express C as just the plain C instead of C raised to the power 1. And then we have a raised to the power of 3. Okay? All right, now, this is what we're going to do. Since we have a negative, all right, cube, that's outside of the parentheses, it's a raised power, we're going to apply the reciprocal, which is the quotient rule, negative quotients, all right, you remember. And it's based upon what I was saying. It's based upon this, all right. Any quotient that has a raised negative power, we find the reciprocal, all right. We find the reciprocal, all right? And that's what we're going to do. We're going to flip it. So we have the negative. This becomes 2b as the numerator, and then a squared c raised to the power of 3. And it becomes positive, all right? And then the last step, since we have everything in the parentheses taken care of, we have your exponent. And we apply the raised power rule, okay? And this time what I'm going to do, I'm going to show you how the powers are expressed, okay? Just to show you the work. All right, so as we apply it, just to show you what I mean, if you raise a power of another number, the numbers are actually a number raised to the power, or base raised to the power, you multiply the number times itself, and I'll show it to you right now. Okay, so we're going to apply. It's more like the distributive property in a way, but let's go ahead and apply. So we have 2 to the third. I'm just showing the work this time, okay? And then b raised to the 4th power times 3. So any time that you raise a power of another power, you multiply the exponents, okay? You multiply the exponents over a squared raised to the power of 3, all right, the product of 3, and then we have c to the third, because the number c to the, just a regular c is the power of 1, so you actually multiplying 1 times 3, which is 3. And then we find the next step, then the negative, and then 2 cubed, which is 8, b to the 4th times 3, which is 12, right, over a raised to the power 2 times 3, with the powers, 6, and then we have your c to the, we have your c to the third, all right, yes, okay, and that is your answer, okay. All right, my name is Irvin Howard, and I hope you enjoy solving the exponential expressions using the steps involving PEMDAS as a checklist, along with a little formula writing. If you have practice in your formula writing, will help you to be cognizant of your operations and identifying mistakes, in especially when you're involving negative numbers. You see, if you do that, you can clearly see that. And again, I encourage the students to practice their formula writing so that they can keep up with the steps. You're not in a hurry, especially when you're taking a test or an examination. Use that time wisely to go back to your steps and apply the formulas and show your steps so that you can go back and revert back to where you left off if you are kind of lost or you misstepped something in your instructional progress. You have a great day. Thank you so much.